Hello everyone, in this video we're going to be talking about test 1 review. So we'll go over all the solutions and I will give you more specific information about the test. The first question is from section 3.2. On the test, the table will be complete, and by that I mean it will look like this. So all you have to do is use the formulas and use these sums to get the answer. The first question is asking you to find the mean. Remember that the mean is the sum of the frequencies times the midpoint divided by the sum of the frequencies. In our case, the sum of the frequencies times the midpoint is 131, and the sum of the frequencies is 14. So all you have to do is plug it in and divide. So 131 over 14 is around 9.35. So that means that the mean for the group data is 9.35, and that's it. The second part of the question is asking you to find the variance in the standard deviation. So recall that the formula for the standard deviation for group data is the sum of the frequencies times the midpoint square minus the sum of the frequencies times the midpoint square, everything divided by the sum of the frequencies, and all of this divided by the sum of the frequencies minus 1. If we plug in the values, which we have all of them here, this gives us 1791 minus 5 minus 131 squared. Remember, the sum of the frequencies is 14, and 14 minus 1 will give you 13. Once you use a calculator here, just be careful to use the order operations. Square this value first, divide by 14. Whatever you get from here, subtract it from this number, and whatever you get from that, divide by 13. Once you do all of those calculations, you will end up with 43.52. Since what you want is the standard deviation, remember that the standard deviation is just the square root of that number. So this is around 6.6. And that's it for question 1. Question number 2 covers sections 3.1 to section 3.3. The first question is asking you to find a percentile to figure out how much is P87. The first thing you have to count is how many you have in the sample. In our case, N, or the sample size, is 21. For part A, it's asking you how much is P87. Remember here, that means K is equals to 87. So for step 1, the formula says N, which is 21, times K, which is 87, divided by 100. This gives you 18.27, which is a decimal. Remember, that you get a decimal, you have to round it to the next whole number. In this case, for step 2, the location of P87 has to be the 19 location. Since this was a decimal, you have to round up. Now, which one is the 19 location? You start counting from here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you keep counting. Eventually, you'll get there. And the 19 location happens to be this, so you can check. So therefore, that means for the step 3, the P87 is equals to the number 40. And that's it. Now part B is just asking you to find the average. Remember, to find the average, all you have to do is add all the numbers and divide by the total. So in our case, it will be 5 plus 5. Just keep adding everything until 50. Divide by the total, which is 21, which is around 18.05. Alright, so to find the IQR, remember that the IQR is equals to Q3 minus Q1. But Q3 is the same thing as P75, and this is P25, which means you have to do exactly what we did here. You can also use the calculator. The calculator, if you have a TI 83 or 84, you will find Q1, Q2, and Q3 for you. And actually, to do that, all you have to do is go to the calculator, then go to Stat, Edit, input all this data. Make sure you input this correctly. You make a mistake inputting the data, everything will be wrong. So make sure you put the data in one of the lists, L1 or L2 or whatever is free. Then go again to Stat, and then go to Calculate, and then pick one variable, Stats, and just make sure you put the right L1 or L2, whatever you have the data. This will give you Q1, Q2, and Q3, but it will not find something like P87. So you do that, or you do this the long way. You can check the Q3 is equals to 26 and Q1 is equals to 8. The calculator may give you the answer 0.5 off, and by that I mean the calculator could say this is 26.5 or 25.5, or this one is 8.5 or 7.5, and either one is fine. So you can use whatever the calculator gives you. So the IQR in our case, from here you have the IQR is Q3 minus Q1, which is 18. That's the answer to part C. To find the outliers, remember you need to find an upper bound and a lower bound. The upper bound is Q3, which in our case is 26, plus 1.5 times whatever the IQR is, which in our case is 18, and this is equals to 53. The lower bound is Q1, which is A, minus 1.5 times the IQR, which is 18, and this happens to be negative 19. If we draw a graph between the lower and upper bound, this is the lowest you can go, this is the higher you can go. Anything between here and here is okay, and anything here will be an outlier, or anything in here is also an outlier. Since all the data we have falls between 19 and 53, that means we don't have any outliers. So you don't have to have outliers, and if you have more than 3, you should check your answer. So that's it for part D. The final number summary, remember, is the lowest number Q1, which is P25, Q2, which is P50, Q3, which is P75, and the highest In our list, the lowest number is 5, Q1 is 8, Q2 is 12, Q3 is 26, and the highest is 50. Remember, if you have a calculator, a TI 83 or 84, they will find these values for you as long as you use these commands. But this doesn't work for any other thing besides 25, 15, 75. The last part of this problem, they ask you to draw a black spread, which is technically just drawing the 5-number summary. So for that, you literally just do a box. This will be the highest, this is the lowest, and this corner, this is Q1, Q3, do 2 lines for the median, which is also Q2. This is the lowest, or the minimum, this is the highest. That's it. So in our case, it's 5, 8, 12, 26, and 50. And that's it. Question number 3 is from section 4.2. For this question, remember, the best thing is to do a Venn diagram before you start the problem. If you have the right Venn diagram, everything will be easy. So in this case, you have 100 people, which they're either Mexican or they're Catholic or other. So in this case, it tells you that you have 8 that are both Mexican and Catholic. You have 25 people that are Mexican. That means this one has to be 17, so that this adds to 25. And then it tells you have 32 people that are Catholic, so that means this has to be 24. Since together you have 100, that means you have 51 people that are neither Mexican or Catholic. Now mathematically, remember, that means these are Mexican and Catholic. These are the people that are Catholic but not Mexican, and these are the people that are Mexican but they're not Catholic. The first question is asking you what's the probability that a person is Mexican or Catholic. This is the happy face formula, so you use the formula. It says Mexican plus Catholic minus all Mexicans and Catholic. If you use the formula, this is 25 over 100 plus 32 over 100 minus 8 over 100. If you add all of them, that will give you 49 over 100. You can also notice that if you add this plus that, it will give you exactly 49. So therefore, the happy face is just the addition of these 3 parts. So you can see it that way too. Part B is asking you how many people are Mexican but not Catholic. So that should be obvious. That's the answer to this. The question is Mexican but they're not Catholic, so that's 17 over 100. Part C says the person is neither Catholic or Mexican, so that's the people outside. So this is the probability that the person is not Mexican and not Catholic, so that's 51 over 100. Part D is conditional probability, because it starts by if. Remember that this means given. So it says given that the person is Mexican, what's the probability that the person is not Catholic? You use the formula. This is not Catholic and Mexican. divided by the probability that is Mexican. Remember, this goes down. So how many Mexican people you have? 25. And how many people that are Mexican but not Catholic? That's 17 over 100. Remember, that comes from here. Mexican and not Catholic, or not Catholic and Mexican. Then just simplify this. The 100s cancel, so this is 17 over 25. The last part is asking, are these two events independent? Remember, when they ask you for independence, all you have to do is check this. Is the probability of Mexican and Catholic equals, that's the question, to be probability of just Mexican times Catholic. This is A over 100. Is this the same as 25 over 100 times 32 over 100? You simplify this. This is 8 times 4, that's just fractions. This is 25 times 4, so this cancels. This cancels down, so this is A over 100, and yes, they equal to each other. So yes, they are independent. Question number 4 is from section 4.2. The first thing you have to do is add the rows and all the columns, and the total in our case is 250. So the first question is asking you, what's the probability that a randomly selected person is not Republican? Not Republican means it has to be Democrat or from the Green Party. These two are mutually exclusive, so you have to add it up. So 80 plus 90 is 170. So this will be 170 over 250. Do not simplify the answer, so this is enough. Part B is asking you, what's the probability that a randomly selected person is Democrat, or, remember, or you have to use the addition formula, or a college student. So this is Democrats plus college students minus all the Democrats that are college students. Then you look to the table. The first one is 80 over 250 plus 100 over 250 minus 20 over 250, and this adds to 160 over 250. Part C and Part D are from section 4.3. The question in C starts with if. Remember, that means given. So you have to use the conditional probability formula. This is asking, given that the person is Republican, what's the probability that the student is a college student? So if you apply the conditional formula, gives you this. Then you look to the table. Republicans, you have, remember, 80. So the probability is 80 over 250. And the number of college Republican is 30. So simplify, and this is 30 over 80. Again, do not simplify. Just leave the answer like that. Part B is asking you again if they are independent. So remember, when you check if something is independent, all you have to do is this. Is the probability of being from the Green Party and, so it should be N, a college student, the same thing as being a member of the Green Party times being a college student. This is 50 over 250 from the table. And the question is, this equals to 90 over 250 times 100 over 250. In this case, you can check that they are not the same, but you have to check. Remember, the previous problem, it was independent, even though it didn't look like it. So here, since these two don't equal to each other, that implies they are not independent. And that's it. Question number 5 is also from section 4.3, and this has to deal with independence. So it says, according to a local survey, 55% of Angelinos pray every day. And if you randomly, so this is the part that guarantees that things are independent, you select 4 Angelinos, what's the probability that all pray every day? So remember, the probability that the first person prays or any of them prays is 55%. So the only way you can have all people to pray, that means that the first one has to pray, and the second one has to pray, and the third, and the fourth, because you have 4 people. So by independence, this is 0.55 times 0.55, and so 4 times, because you have 4 students, and this is around 0.0915, or simply you can just leave the answer like 0.55 to the 4th power. Now, what's the probability that none of them pray every day? In case you haven't noticed, this is not the complement of this. So the answer to this is not 1 minus this. The probability that none of them pray, you do the same thing as this. The only way you can have 4 people to not pray, that means that the first one didn't pray, and the second one didn't pray, and so forth. That means none of them. This will be 0.45 times 0.45 times 0.45 times 0.45. So you have 4 people. The only way that all of them don't pray, the first one has to say no, the second one has to say no, the third one, and the fourth. And you multiply, this is around 0.04110. Now the last part is asking what's the probability that at least one pray. Remember, how do you deal with at least one? Well, the probability of at least one, you use the complement is 1 minus the probability that none of them prays. This is 1 minus 0.04110, which is the answer from here, and that gives you around 0.959, and that's it. Question number 6 is from section 4.5, and this has to do with base rule. And remember, the best way to deal with this problem is to do a tree diagram. This one says that 45% of the population is male, so that means that 55% has to be female. It also tells you that if the person is male, there is a 12% chance that he will smoke, which means there is a 88% chance that he won't smoke. They also tell you that if it is female, there is a 8% chance that the person will smoke, so there is an 82% chance that she will not be a smoker. So the first question is asking you what's the probability that a person is a smoker. So the only way you can get to a smoker is the person is male and smokes, or the person is female and smokes. So if you multiply, you end up with 0.45 times 0.12. This means male and smokes plus female and it smokes, and this is around 0.098. For part B, you can go through the whole tree again, or you can just use the complement, because the probability of having a smoker is the same thing as 1 minus the probability of being a smoker. In our case, this will be 1 minus the answer to part A, which is 0.098. This is around 0.902. Part C is what we call Bayes' rule. This is just a conditional probability because of the if. Remember, that means given. So the question says, given that the person is a smoker, what's the probability that the person was male? If we use the conditional formula, this is the probability that the person is male and smoker, divided by the probability that is a smoker. Just go back to the tree diagram. This one is 0.098, which is the answer to part A of the problem. This is part A. And the top means male, which is 0.45, and is a smoker. This is around 0.55110 or 0.6, depends how you want to round. And that's it. Number 7 is from section 4.4. So the iPhone has a password that consists of 4 digits, and they can be repeated. So you can repeat it. That means you have 10 choices for this one, 10 for this one, and so forth. So this gives you 10 to the 4, which is 10,000. So that means you have 10,000 different choices. And that's it. So the next part says, if your boyfriend has an iPhone with a passcode on it, what's the probability that you will get the correct answer on the first try? So the probability of the correct answer or the correct password, answer the correct password on the first try, it will be just 1 over 10,000. That's it. Part C says the boyfriend has the password, so if you fail 3 times, the iPhone will lag. Well, if you fail 3 times, that means you had to fail the first time and then fail the second time and then fail the third time. This is not independent, but you can use the multiplication property anyways. The probability you'll fail the first time is 9999 over 10,000. If you fail once, now you're not going to use the same password, so you have this many left. The probability you're going to fail is 9998. And if you fail twice, then you have these many choices now and these many chances of getting it right. In this case, all of this cancel, so you end up with 9997 over 10,000. So that's the probability that the iPhone will lag, which means you have to fail 3 consecutive times. The next question is also from 4.4. The first thing you have to do is count how many you have total, and you have 30 between Americans, Asians, Africans, Europeans. If you add it all, you have 30 people, so you need to figure this out first. The next thing you have to figure out is if you are using combinations or permutations. Since the order doesn't matter, since it's a committee, then you're going to use combinations. The next thing you have to figure out is what is the sample size. The sample space. The sample space is going to be all the different ways in which you can choose 5 people from 30, and this will give you the sample space. So the first question is asking you, what's the probability that you will have 2 Americans, 2 Africans and 1 European in the committee. Remember, the sample space is 30, choose 5, because you're picking 5 and 30. Now you have 8 Americans and you want 2. You have 7 Africans and you need 2. You have 5 Europeans and you need 1. And finally, you have 10 Asians and you don't need any. Remember that anything choose 0 is always equals to 1. And it's a good idea to write this part so you can check you're doing this correctly. Remember, all the numbers on the left side when you add it up has to add to this one, and all the ones on the right side have to add to this one, which it is the case. For part B and part C, we use the same information. Part B is just asking what's the probability of getting 4 American. Remember, you're still picking 5 people from 30, so the sample space is still this. You want 4 Americans, so it's 8 choose 4 times. You have 22 people left, but you still need to pick 1. You need to have this if you want the answer to be correct. Remember, you add this 2 has to give you this one, and then you add this plus that has to give you that one, which is the case, so this is good. For part C, it's asking the probability of at least 1 European. And remember that the probability of at least 1, the best way to approach this is to do the complement, which will be 1 as the probability of no Europeans. And this is 1 minus you want no Europeans. The bottom is going to be 30 choose 5 for all of these problems because that's the sample space. So you have 5 Europeans, you want 0. Then you have 25 people left to choose 5. And that's it. On the test, just leave the answer like this. There's no need to simplify, so just leave it like this. Do not simplify. The last part is the true or false section. This one, all you have to do is think a little bit, and it should be fine. Part A is saying that if the mean is negative, the coefficient of variation is positive. Remember that the formula for the coefficient of variation is the standard deviation over the mean. Remember that this value is always positive. So if you divide a positive number by a negative number, the answer will be negative. So therefore this is false. Part B says if A and B are independent, then the probability of A and B is equals to 0. This is false because remember, independent means the probability of A and B is the probability of A times the probability of B. If the probability of A and B is equal to 0, it means they are mutually exclusive, not independent. Part C, the median and Q2 are the same. This is true. Why? Because remember, the median is P50 and Q2 is also P50, so they are the same, so that's why it's true. Part D, if A and B are mutually exclusive, then the probability of A and B is equals to 0. Remember, mutually exclusive means the probability of A and B is equals to 0, not 1. So therefore this is false. Part E, if the complement of A is 0.7, then the probability of A is 1/2. This is false. What will make this true? Well, if this was 0.3, because remember, this plus that has to equals to 1, and 0.5 plus 1, plus 7 is 1.2, so therefore this is false. Part F, the median and the mid-range could be the same. Well, that's true. They don't have to be the same, and they are actually not the same most of the time, but they could be the true, so that's fine. If A and B are independent, then the probability of A given B complement is equals to A. This one is probably the most tricky one, and it is true. Here is the reason. The probability of A given B complement is the probability of A and B complement over the probability of B complement. Now, since they are independent, that means that you can break this into a multiplication, and they cancel each other, which gives you just probability of A. So this is true, and this is probably the most difficult question. Part H, the probability of A and B is always greater than the probability of A. Well, this is actually false, and the reason is this. If you do a Venn diagram, if you have A and B, this part here represents A and B, and you can see right away that this area is less than A. So A and B is always going to be less than A, or A and B is always going to be less than B. If the inequality was going the other way, like this, then it will be true. So in this case, the way it's written, this is false. Part I, it says the IQR is equals to Q3 minus 1.5 1.5 Q1. That's wrong. This is the correct formula, so this is false. And finally, if A and B are independent, then the probability of A and B is the probability of A plus the probability of B minus the probability of A times the probability of B. The key here is that it's independent. Remember, the formula is usually like this, and this doesn't need A and B to be independent. So this is usually the formula, the addition formula, which you have in the formula sheet, addition formula. Now remember that if A and B are independent, this becomes a multiplication. Only they are independent. So therefore, this is true, since this is equals to this. So this one is true. And that's it. And good luck.